All right, so guys, we're going to start talking about these things called circular functions and introducing the idea of a unit circle, which I've mentioned the unit circle before. We've kind of started to talk about this circle where we have the degrees and the radians and all of these measurements on here. So starting with the definition of what a unit circle is, it's a circle with radius 1. That is centered at the origin. So it's essentially just the most basic circle that we can have. We consider this to be centered at the origin, and then it's got a radius of 1, which means from the origin we're going 1 unit in every single direction. All right, so using that, we are going to be able to come up with our sine and cosine values. And so this is going to be the main idea that's going to take us through the unit circle, which is kind of like the big culmination of a lot of this trig stuff that we've had. And it's going to be super, super important for those of you that take any pre-calc or beyond. All right, so we've got, first of all, this is the function that we are using. So you remember just in the last chapter we were doing these circles. So this means that the circle is centered at the origin. This means that it has a radius of 1. Because remember, we square the radius and put it right here. So that's our function for this circle that we have right here. So remember, from a previous section, we had that sine of theta was equal to the y value divided by the r value. So for us here, our radius, like this measurement right here, is 1 unit. So it's just the y value divided by 1, which is just the y value. And then our cosine, remember, is the x coordinate divided by r. And again, r is just 1, and so this reduces down to just x. So this is the part that's super, super important. Wherever you are on that unit circle, if you say that you have an xy coordinate point, as long as you're on the unit circle and this measurement is 1, your sine is just going to be whatever the y coordinate is, and then your cosine is going to be whatever the x coordinate is. This only holds when you're on the unit circle, and that's just because this measurement is 1, but it is super, super important to know that if you are on the unit circle, this xy point that we have right here, whatever the point is, the x coordinate tells us what the cosine of that angle is, and then the y coordinate tells us what the sine of that angle is. So that, like I said, is going to carry us through and get these really important ideas of the unit circle that we're going to be working with. All right, so this first example, they're going to give us a point. And if they give us the point, remember, this is on the unit circle, which means this is our cosine value, and then this is our sine value. We want to find the rest of the 6 trig functions. All right, so it's going to be easy to just identify, well, here's the sine, here's the cosine, and we'll kind of put all the rest of the pieces together. So we know that the sine of theta is just the y value, so that would be -3/4. And then cosine is the x value, so that would be square root of 7/4. The other two of the other ones are going to be super easy to find, because remember, cosecant, you just flip, so it'd be 4/-3, and then same thing with secant, we just flip that one, so it'd be 4 over the square root of 7. We always want to square root. Well, we don't want to square root in the denominator, so we want to rationalize those square roots. So this ends up being 4 times the square root of 7, and then remember that denominator would just be 7. So that's the rationalized version. So we got 4 out of the 6. Tangent is going to require a little bit of work to actually simplify down. So the tangent value, remember, is the y coordinate divided by the x coordinate. So I have this y coordinate divided by this x coordinate. So instead of dividing fractions like that, what we're going to do is multiply by the reciprocal. So we are going to take the numerator and then multiply it by the reciprocal of the denominator. So flip to write 4/√7. So first thing that will happen is these 4's will cancel. And then next thing that will happen is we want to make sure we're rationalizing this denominator. So we've got -3 times the square root of 7, and then over, remember, this will just be 7 when I rationalize that out. All right, and our last one is cotangent, and that's just the reciprocal of tangent. So I'm actually going to take this version of it and just flip that, because if I flip this, I'd have to rationalize the denominator again. So I'm just going to flip this. So instead of -3/√7, I'm going to have √7/-3. So that is my cotangent. So I've got all 6 of them there. All right, so that is the introduction to the circular function idea. So we're going to spend a lot more time on that when we do our whole unit circle video. For now, we're going to visit the idea of a periodic function, and periodic functions are going to take us into 12.7 and 12.8 when we start graphing our sine and cosine functions as well. So here's the first idea of our periodic function, the definition, I suppose we could say. So periodic functions, any function that we're looking at, we can say that it has y values that repeat on regular intervals. Okay, so you can see some of the shapes that we have on this page. We've got this one, we've got this one. They just repeat themselves. It's like a pattern that just repeats itself over and over again. And we call them periodic because they each have something called a period. So however long it takes before the cycle repeats again, we call that the period. So this one, the cycle goes down to -1, up to 1, and then it starts repeating. So this is considered to be one cycle, and so it takes 360 degrees to get through that one cycle, so we refer to that as the period. So this right here, like this little cycle, that means in this time period, you've got one complete pattern happening. So one complete pattern happens, that's what that cycle is considered. And then the period, so definition of a period is the horizontal length of one cycle. Okay, so the horizontal length of one cycle. So that's what it means. When you're asked for the period, it means the horizontal length of one cycle. So with example 2, for instance, when it says to determine the period, you want to figure how long the cycle goes before it starts repeating itself. So this is the start. It goes down, across, up, and then right here, this moment is when it would start to repeat itself. So when you figure out when it would start to repeat itself, you can figure out exactly what the period is. So this end to end, this goes from 0 to pi. And so the period would be pi. You can also see like it repeats itself again from pi to 2 pi. So you could do 2 pi minus pi to get the period that way. It's kind of like subtracting the end minus the beginning of one of those cycles. All right, so that would be your period. And then these things that occur in nature. So we've got, well, not nature, I guess in real life, the way that wheels revolve, pedals on a bike, carousels, objects in space, these cycles are all periodic. You can picture like the position, say you're on a carousel, so you've got the horse on a carousel, that position is given periodically. So like every certain number of minutes or certain number of seconds, you end up right back in the same place where you started. And so this example is gonna be pedals on a bike. So the pedals, it's in all of these different positions. And so someone is riding at kind of this steady speed here, and you've got the position of the bike pedals going in this periodic fashion. Okay, so here's what we're gonna start to set up. We're gonna make a little table and set up a function based on the periodic position of these wheels. Okay, so first thing we want to pay attention to, we've got this little, all of these values here going 0 seconds and then all the way around to 2 seconds. So this little picture kind of gives us all the info that we need, and it's got the different heights. So this is the bottom of the cycle, this is the middle, and then this is the top is 18 inches off the ground. So first we're gonna make a table. All right, so this table we're gonna go with time and then height. So those are our two variables. Okay, so you can see everywhere that it is on there. So you can see everywhere from 0 to 2 seconds. So we're gonna start by finishing off this table with 3, 3.5, fill in all these different values. All right, so it goes through the cycle, so 0, 2, and so when it starts to repeat itself, it takes 2 seconds to get to this point. So this would be 2.5, and then this would be 3. So 3 would be in the same position as 1, so this would be 4 inches. Okay, and then 3.5, it would be right here, so that would be 11 inches. 4 would be back up at the top, so that's 18 inches. 4.5 would be over here at 11. And 5.0 would be down here, just 4 inches off the ground. So you can see that cycle just repeats itself, just over and over and over again. So first thing we want to identify, we can talk about the period of the function. So the period is just how long it takes for the cycle to repeat itself. So that would be 2 seconds. And then we're gonna graph this function. So we're gonna take the values that we have based off this picture, the values that we have on the chart, and we're just gonna graph it. All right, so I'm going to go in half-second intervals here. Okay, so those are 5 seconds. And then we want to make sure we can get up to a height of 18. So let's go by maybe 3. Okay, so that reaches our full height of 18. So what we're going to do is we're going to plot the points that we have and then make sure we plot everything that's coming off this chart as well. So at 0 seconds, the height is at 18. So that would be right there. And then at 0.5 seconds, the height is 11. So if this would be 9. So 11 would be like right there. And then 1 second, it's at 4. So right around there. 1.5 seconds, it's back up at 11. 2 seconds, it's back up at 18. And then this cycle just starts to repeat itself. So we didn't have mark on anything for 2.5, but 2.5 would be right here. So we can mark that back at 11. 3 we said is down at 4. 3.5 is back up at 11. 4 is all the way up at 18. 4.5 is at 11. And then 5 is back down here at 4. Okay, so you can see all these values. And it's not, since this is a circle, we're not going to do this like big zigzag shape. It's going to be more rounded and smooth and kind of match with the circular pattern that this petal is taking on. So it's going to start here and it just sort of like rounds through these points and just does this smooth, rounded sort of connect the dots here all the way through these points. And it would just keep repeating that pattern over and over and over again. So that's, at any given time, if you wanted to know where the wheel was, it would be somewhere given this height if you match it over with the other axis. So we've got T for time, H for heights. All right, so I believe I'm going to stop there because I'm going to do a second video for the unit circle. Yeah.